Hello everyone. Here I will be solving model paper given by the PU Board of Karnataka. Keep in mind that passing in board exams is very easy, and that too, if it's PUC of Karnataka, it is even more easier because of the choices given. In fact, the entire paper with choice included is for 140 marks, out of which student to pass in theory should get at least 21 marks. So getting 21 out of 140 is very easy, and if we multiply in terms of percentage, it is just 15%. Means a student should be able to get at least 15% of the marks in this paper to pass. Now even with less preparation, even with minimum preparation, a student can easily score 21 marks in this paper. Even those students who haven't prepared anything, who don't even know basics of anything, even such students can pass the examination provided they follow the tips given in this lecture. Now here, I will not only give answers to the questions given here, I will also tell what is important around that topic. So the solution could be quite elaborative. It will be lengthier because there will be some points explained also. So bear with it and try to make best use of this videos. And also, if time permits, I will create a model paper, just a second paper, and solve it. But for now, I'll solve this paper, and maybe we can take up one more paper and solve later also. So let's begin. The first main is 1 markers, where a student is expected to answer any 10 questions. Now here, there are 15 questions, out of which student needs to answer only 10 questions. So even here, there's enough choice in the questions, and also many questions are straightforward. So let's begin. Question 1 says, write the physical quantity whose SI unit is coulomb. The answer is straightforward, it is charge. Now here, a question could be asked another way around also. The question could be to define what is 1 coulomb. So to define what is 1 coulomb, now 1 coulomb can be defined from Coulomb's law. It says the force is equal to 1 by 4 pi naught Q1 Q2 by 1 by r square, and we can write this also as F is equal to K into Q1 Q2 by r square, where the constant K is 1 by 4 pi naught, is 9 into 10 power 9. So if we have two charges, say let us call this as Q1 and Q2. Suppose if the distance between them is say r, if this distance between them is r, which in this case if we take it to be 1 meter. So if we make both Q1 as 1 coulomb, Q2 as 1 coulomb, and also put r as 1 meter, then from this formula what we get is, there is this formula, we get F is equal to 9 into 10 power 9, because Q1 is 1 unit, Q2 is 1 unit, and even R also is 1 unit. So we can say that the charge on each charge is said to be 1 coulomb if each charge exerts a force of 9 into 10 power 9 Newton for a operation of 1 meter. The answer for this is only charge, but even this could be asked as a possible question. So by doing this, more questions are covered, and also a student is prepared to answer what could be asked in topic. Question 2 says, define linear charge density. It is defined as, the symbol for this is lambda. Lambda is defined as charge by length. So linear charge density is defined as charge per unit length, or mathematically it is given as charge by length. Sometimes they may ask you to define what is area charge density as well as volume charge density. The sigma, called as areal charge density, this is given by charge by area, and could be rho, which is defined as volume charge density, which is given as charge by volume. So anyone could be asked as one more question. Don't always expect that whatever is given in model paper, the same thing will appear in examination. Model paper is just a blueprint to tell what kind of questions could be asked. And sometimes some questions may directly come from here also, but not everything. But by going beyond this question given here, looking at topics which are connected with this topic, more topics can be covered. In that way, a student can learn better. Now, other question which can be asked here is, question could be to write the SI unit for each of this. So here it would be coulomb per meter. Here it will be coulomb per meter square. Here it is coulomb per meter cube. So even this could be asked. Question 3 says, how does resistivity of a nichrome vary with absolute temperature? The answer is straightforward. It varies directly. There is no need to write beyond this. But in textbook, set of graphs is given. That is, 3 graphs are given for resistivity versus temperature for 3 different materials. One is copper, nichrome, there is semiconductor. The corresponding graphs are given here. Now, the question could be asked in other round also. They may ask you to draw a graph for resistivity versus temperature for any one of this. So it is better that a student learns these graphs also, which may be asked. So for copper, it's increasing slowly and then there's a abrupt increase. For nichrome, it increases linearly or directly, is what has been asked in the question. And for diode, it decreases. So they may ask you name a material for which resistivity decreases with temperature. The answer is semiconductor. Understand these things also. Don't just by hand answers for a given question. It's of no use. Go beyond that, as been done here. This is number 3. Question 4 says, the colored rings marked on a carbon resistor are red, red, red and silver. What is the tolerance of this resistor? If they ask you to find its resistance, in that case, here it's only tolerance. So keep in mind that the last color would give the tolerance, and learn this table where they are starting from black, brown, red, orange, yellow, green. Because since a question is asked something related to color coding, the question could be to ask to find what is resistance for a given color also. Not have been asked here, but there is a chance of it being asked. So to remember this, just remember the synonym that B.B. Roy of Great Britain B.B. Roy of Great Britain had a very good wife. That's how we remember this. Again, this is a way to remember what has been given here. The numbers could be starting from 0. So it is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Remember, the first one is black, so it takes care of here. And the B here is for blue, and here this V stands for violet, for white. Rest are straightforward. So here we'll have 3 colors plus tolerance. So for first 2 colors, for example, in this case, color is red, red, red. Last is silver. In such case of color coding, the first 2 letters would indicate the numbers directly. Example here, red stands for 2. So it will be 2, 2. The third one is multiplier. Means it is 10 power to the number given here. Example, if it is green, it is 10 power 5. If the third one is, say, yellow, it will be 10 power 4. So the first 2 numbers are just the numbers, and third color is a multiplier. It means it will be this number into 10 power the multiplier, which in this case is 2. Suppose it's like red, green, and then red, and then something else. Red stands for 2, green is for 5. It will be 2 into 5, 25, into the third is multiplier, so into 10 power, red is 2, 10 power 2. It becomes 2500. In this case, it is 2200, and then tolerance is plus or minus. There are 3 colors here. The colors are gold, silver, and then no color. For gold, it is plus or minus 5%, and what is given is silver here, which is plus or minus 10%. So the answer would be 2200 plus or minus 10% in terms of ohm. But here, what is being asked is only the tolerance, not the resistance. I did this to tell you how to solve if such a question is given. Here, just remember that the last color is generally silver, gold, or no color. That will be tolerance. In this case, it is silver, so it will be plus or minus 10%. That is what is tolerance. Question 5 says, what is Lorentz force? Now to define this, we can say it is the total force acting on a charged particle due to the presence of electric and magnetic field. Thus, suppose if this is sufficient right answer. Now to understand this, suppose if you have a charged particle, and then if we have a magnetic field, and somewhere at some angle if we have an electric field, and if a charge enters, the velocity v, charge is q. In this case, the charge would experience 2 forces. That is, charge would experience a force because of electric field as well as magnetic field, because both would exert a force on this charge. Therefore, the total force on the charge would be the force because of electric field and the force because of magnetic field. This equation solved further, force is equal to electric field is given as q into E plus magnetic field is given as q into V cross V. This force called as Lorentz force. Here we asked only the statement, so this is sufficient. In case they ask a formula or equation for Lorentz force, is given by this form. Since the force is a vector quantity, we need to add them vectorially. This is called as Lorentz force. Here there is another important concept called as velocity selector. Now in this case, there can be a possibility where the electric force and magnetic force will be equal in magnitude but in opposite direction. Means these two can cancel each other. In such case, net force becomes 0. In that case, Q into E is equal to Q into V into B, because if the angle between velocity and magnetic field is 90 degrees, then sin 90 is 1. So we get Q into E is equal to Q into V into B. From here, Q gets cancelled. Therefore, what remains is E is equal to V into B, or V is equal to E by B. This condition called as velocity selector. Given this, the important question. Question 6 says, state Gauss law in magnetism, called as Gauss, not Gauss. So there are two forms of Gauss law. One form of Gauss law is in case of electrostatics, and other is in case of magnetism. But any form of Gauss law is given by the form the total electric flux. That is, in this case, the flux is given as V dot dA. This is definition of magnetic flux. So the total magnetic flux through any closed surface is equal to 0. This is Gauss law in magnetism. Again here, a question which could be asked is, they may ask you, so what is the significance of Gauss law in magnetism? In such case, we can say that since the total magnetic flux is equal to 0, it implies that magnetic monopoles do not exist. Even this is a very important statement, or the question could be clubbed in two ways. The question could be to state Gauss law in magnetism and explain its significance. So these two can be combined together to be asked as a 2-mark question. If to recall as to what is Gauss law in electrostatics, then there it is electric flux, because it is electrostatics. The total electric flux to any closed surface is equal to 1 by epsilon times the total charge enclosed by the surface. This is Gauss law in electrostatics. Even this is a very important statement or a question. Question 7 says, draw the pattern of magnetic field lines of a bar magnet. Just learn the diagram. It's given here, where we have bar magnet. So one end is taken as north pole, other taken as south pole. The magnetic field lines will originate out of the north pole and they would enter through the south pole, and these would form closed loops. Very important. The magnetic field lines will form closed loop like this. So what is important is to draw the field lines inside the magnet also. Inside the magnet is from south to north. So this is the magnetic field lines because of a bar magnet. You get similar kind of field lines even for a solenoid or for a current carrying circuit. Just practice diagrams of magnetic field because of a solenoid as well as because of a current carrying loop, and also because of electron motion. At least practice the magnetic field because of a solenoid as well as a current carrying loop. Question 8 says, what is patchless current? So we know that whenever current flows in a circuit, there will be some resistance because of which there will be power consumed or heat produced. But here, question says what is wattless, which means what is powerless current. Now don't mistake that current is zero here. It isn't. Current is flowing. So wattless current is seen in case of AC circuit. You can say that this is a current in AC circuit such that the average power consumed is zero. Again, don't by heart the statements word by word. Not required. Understand the meaning beyond the statement and write in our own words, because physics is best learned by writing in our own words, except for laws, because laws can't be interchanged. Except for laws, the statements or principles, try to write in our own words. Just understand the concept, because if a student tends to memorize it, the student will not be able to recall. Understand the idea behind the particular concept, the principle, then learn to understand it. So here we can say, if we have a AC circuit and if current flows in a circuit, then the average power, this is very important, the average power consumed is zero. Such current called as wattless current. Question 9 says, mention the angle between electric field and magnetic field in an electromagnetic wave. The answer is 90 degrees. So to show it, there is a diagram shown here which is representing a electromagnetic wave. There will be two kinds of fields called as electric fields and magnetic fields, as seen here. The blue color indicates electric field and the red one indicates magnetic field. As seen in the diagram, the angle between electric field and magnetic field is 90 degrees. Electric field is normal to magnetic field, and also the wave moves in a given direction. Let's call that velocity as some v. Remember, the angle between electric field, magnetic field and v, the angle between any two components is 90 degrees. Example, look at here. The black line indicates the direction of propagation of the wave. The angle between this and this is also 90 degrees. The angle between the magnetic field and this is also 90 degrees, because magnetic field or the oscillations will be in this direction. So the angle between electric field and magnetic field, or electric field and velocity, or v and velocity, is always 90 degrees. To understand this, think of x, y and z axis. Suppose electric field is along, say, e direction, electric field is along x direction, and this along y direction, then velocity will be along the z direction. The angle between each three would be 90 degrees. Velocity will be along this direction. You can think of electric field, magnetic field, velocity to be along three mutually perpendicular axes. Question 10 says, name the electromagnetic wave which keep the earth warm by greenhouse effect. It is IR radiation or infrared radiation. In your textbook, there is a topic which talks about uses of some kind of electromagnetic waves. So to make it easier, student can prepare like this. Just write each radiation. Example, say like gamma radiation, X-ray radiation, or ultraviolet. Just write the radiation name and at least write two uses of each of this, because they may ask you even a 2-mark question based on this. So for all the waves given, write two use of each of it and learn it, because this is a potential question. The answer here is IR or infrared radiation. Question 11 says, write the condition for diffraction maxima in terms of wavelength of light and slit width. Now here, the path difference for maxima means bright bands is given as 2n plus 1 lambda by 2, and the path difference itself is given as a into sine theta. So a into sine theta is equal to 2n plus 1 lambda by 2. This is the condition for the maxima in terms of wavelength and slit width, where a here is slit width and n could be 1, 2, 3, etc. The question says write the condition for minima. In that case, a into sine theta is equal to n into. This is the condition for minima. Again here n is equal to 1, not 0, keep in mind, 2, 3, etc. This is the condition for minima. 12 says, how does the resolving power of a telescope change on decreasing the aperture? So the formula is given like this. There is no need to write the formula written to tell how to understand the concept here. The resolving power of a telescope is given as 2a by 1.22 into lambda, where this 2a called aperture. We have a convex lens, diameter called as 2a. Some books write as capital D also, doesn't matter. But what matters here is it is 2a by 1.22 into lambda. The question says, how does the resolving power change on decreasing the aperture? From here, if the aperture, which is 2a, is decreased, then the resolving power also will decrease. The answer here is decreasing. As I told earlier, don't just by heart the answers, understand the concept beyond this. This is the formula of resolving power. Since the aperture decreases, even resolving power will decrease. Or the question could be asked another way also. I may ask you how to increase resolving power as a 2-mark question. So if we need to increase resolving power, there are two possibilities. One is we need to increase the aperture. Second thing is we need to decrease the wavelength because it goes inversely. Even this could be asked as a 2-mark question. Similarly, for a microscope, the resolving power is given as 2n into sine beta by 1.22 into lambda, where n is called as refractive index of medium, v is called as semi-vertical angle. So just learn this formula also, because even this could be asked. Again, use common sense to understand when will resolving power increase. 13 says, define impact parameter in particle scattering experiment. That is, what happens is, if we have a nucleus means it will have positive charge. Suppose if an alpha particle is being projected towards the nucleus, suppose it has been going like this, an alpha particle will also have positive charge. Now if we draw a line to the center of the nucleus like this, then what happens in this case is the particle is moving. The broken line here indicates a line to center of nucleus. When this alpha particle, which is positive, is also in motion, then the particles come closer and closer. There is a positive nucleus as well as a positive charge. Then there will be Coulomb repulsive force, because of which it will be pushed away like this. Path is deviated. That is, the particle was trying to go like this, but because of repulsive force, it's been pushed away. So this angle here is angular scattering, and the distance between this to this is called as B, which is the impact parameter. So you need to write this in words. To make it very simple, you can say that it is the perpendicular distance between the direction, means the particle was trying to go along this line, but it has been deviated. So the distance between the direction of the incident beam and center of the nucleus called as impact parameter. Fourteen says, in which type of extrinsic semiconductor holes are minority? There are two kinds of semiconductors, extrinsic, called as N-type and then P-type. In N-type, majority, N-type means this, N stands for negative. As the name tells, N stands for negative and P stands for positive. So, using common sense, we can tell that N-type is negative. So, here majority would be electrons. P-type means positive. It will be holes. In minority is vice versa. If in N-type electrons majority, holes will be minority. Here it will be electrons. Again, this could be asked as 1 mark question. The answer here is, says holes are minority. That will be holes minority between N-type. Answer is N-type. But learn this also, as I've been telling you all, don't just mug up the answer, understand beyond that also, so you can solve more kind of questions. 15 says, draw the circuit symbol for a PN junction diode. This is straightforward. Just draw a straight line with a triangle like this, straight line here and an arrow. This is a symbol for a PN junction diode, where this end of it would be showing the P-type and this is the